Okay, next topic of Unit 551 Analytical Instruments, Unit 1. The topic is UV Spectroscopy. Here we are going to discuss about the principle of the instrument and what are the instrumentation system is going to be used and what are the applications. So this is a general black diagram of the UV visible spectroscopy. Shortly, this is going to be called as UV spectroscopy. Spectroscopy, actually, we have discussed in the previous video regarding what is the basic definitions for spectroscopy, spectrometer, and all. And even we discussed about the Lambert's law because that is going to be the basic law based on which all the instruments are designed. And here, once again, we are going to check with respect to UV spectroscopy. So, what is spectroscopy? It is a measurement and interpretation of electromagnetic radiation absorbed or emitted when the molecules or atoms or ions of a sample moves from one energy state to another energy state. And UV spectroscopy is type of absorption spectroscopy in which light of ultraviolet region, that is between 200 to 400 nanometer, is absorbed by the molecule, which results in the excitation of the electrons from the ground state to higher energy state. So we are going to have here, so what is going to be the basic lab diagram? A chemical is going to be there. It is information source. Then we'll be going to have a transducer, a signal conditioner, and a display system. This is going to be the important parts of your spectrum. The principle of UV spectroscopy. Basically, spectroscopy is related to the interaction of light with matter. As light is absorbed by the matter, the result is an increase in the energy content of the atoms or molecules. When ultraviolet radiations are absorbed, the results in the excitation of the electrons from the ground state towards a higher energy state. So, molecules containing high electrons or non-bonding electrons can absorb energy in the form of ultraviolet light to excite these electrons to higher anti-bonding molecular orbitals. The absorption of ultraviolet light by a chemical compound will produce a instrumentation of the UV spectroscopy. The first light source, the tungsten filament lamps and hydrogen deuterium lamps are most widely used and suitable light source as they cover the whole UV region. So mainly tungsten and hydrogen deuterium lamps are mostly used. And tungsten filament lamps are rich in radiations. More specifically, they emit the radiations of 375 nanometer, while the intensity of hydrogen deuterium lamps falls below 375 nanometer. And monochromata is generally composed of prisms and slits. Okay, most of the spectrophotometers are double beam spectrophotometers. The radiation emitted from the primary source is dispersed with the help of rotating prisms. The various wavelengths of the light source, which are separated by the prism, are then selected by the slits. Such the rotation of the prism results in series of continuously increasing wavelength to pass through the slits for recording purpose. Then the beam selected by the slit is monochromatic and further divided into two beams with the help of another prism. Sample and references. One of the two divided beams is passed through the sample solution and second beam is passed through the reference solution. Both sample and reference solutions are contained in the cells. These cells are made either silica or quartz. Glass can't be used for the cells because it absorbs light in the UV region. Amplifier. The alternating current generated in the photocells is transferred to the amplifier. The amplifier is coupled to a small servo motor. Generally, current generated in the photocells is of very low intensity. The main purpose of amplifier is to amplify the signals many times so we can get clear and recordable signals. Recording devices, most of the time amplifier is coupled to a pen recorder which is connected to the computer. Computer stores all the data generated and produces the spectrum of the desired compound. Applications. Detection of impurities. It is one of the best methods for determination of impurities in organic molecules, and also measuring the absorbance at specific wavelength, the impurities can be detected. Structural elucidation of organic compounds. It is useful in the structural elucidation of organic molecules, such as in detecting presence or absence of unsaturations, the presence of deuterium atoms is the example. And applications, other applications are, it is also used for quantitative determination of compounds, and it is also, this technique is used to detect the presence or absence of functional group in the compound. And many drugs are either in the form of raw material or in the form of formulation that can also be analyzed using this UV spectrophotometer. And UV spectrophotometer may be used as a detector for HPLC, which we'll be discussing in second or third unit.